All right. Hey again, honors chemistry. Now I'm going to do question number 4. This is a bit of a tougher question because it has grams, so I am going to have to convert to moles. So it says when sodium hydroxide reacts with sulfuric acid, which is H2SO4, NaOH reacts with H2SO4, water and sodium sulfate are produced. Water is H2O, sodium sulfate, sodium is Na+, sulfate is SO4 2-. If I crisscross that, this is sodium sulfate. And then the way to balance this is by putting a 2 here and a 2 here. Convince yourself that that's how you balance this reaction. Okay? Calculate the mass of sodium sulfate produced. So in the end, I'm going to have to figure out how much sodium sulfate. When 15.5 grams of sodium hydroxide are reacted with 46.7 grams of sulfuric acid. So I'm going to start up my BCA table. And I promise you, doing BCA tables for limiting reactant problems are going to really help you organize things. Okay? So I'm going to convert both my grams to moles. I have 15.5 grams of sodium hydroxide. Well, I already calculated on the side the molar mass of sodium hydroxide. It's about 40 grams per mole of sodium hydroxide. That's the molar mass. Grams divided by molar mass is moles. Right? I'll put that over here. Grams over molar mass equals moles. Don't forget that. So whatever I have the molar mass to divide by the grams. So 15.5 divided by 40. And I get 0.3875 moles. And I'm going to put that up here, 0.3875 moles. And then I already calculated the molar mass of sulfuric acid. I have 46.7 grams of H2SO4. And I divide that by the molar mass, which I already calculated before, just adding up all the masses of the elements in H2SO4, 2 H's, 1 S, 4 O. I'm going to divide by 98.079 grams per mole. And if I do this math, I will get how many moles of sulfuric acid I have, 98.079. I get 0.476 moles of H2SO4, and I'm going to put that up here, 0.476. Okay? Now, my procedure is whichever reactant gives me my lowest moles of product. And I'm going to use the stoichiometric relationship, so the mole ratios, to figure out how much product I should get from each reactant. So I'm going to split this in half. And I'm going to get 2. Then I'm going to circle the one that gives me the least amount. So, to go from sodium hydroxide to sodium sulfate, it is a 2-to-1 ratio. So you're going to see that I'm going to half this, but I'm going to show you that math. So I'm going to have 0.3875 moles of NaOH times 1 mole, because this is 1, Na2SO4, to 2 moles of NaOH. I'm ending up halving this, right? This is my mole ratio. I always start with what I have, and then I'm multiplying by my mole ratio that I get the ratio numbers from the balanced chemical equation. So I'm basically dividing this by 2. 0.3875 divided by 2. From sodium hydroxide, I will get 0.194 moles. Okay? Now, if I'm using sulfuric acid, this is a 1-to-1 mole ratio. For every 1 mole of H2SO4, I will get 1 mole of Na2SO4. If I had 2 moles, I'll get 2 moles. If I had 0.5 moles like I do, I should get 0.5 moles of this. Since it's a 1-to-1 ratio, the amount of moles are going to be the same. And that comes from H2SO4. Now, because of that, the procedure is to choose the lowest moles of product. Well, right now, my lowest moles of product is going to be 0.194 moles of H2SO4. Na2SO4. My 0.194 is my lowest moles. It comes from sodium hydroxide. I don't have to go backwards. I actually really don't even have to fill in the rest of the table because it's just asking how much sodium sulfate should I get. Well, I'm choosing my lowest moles. choose lowest moles. I cannot have more than what I have. So I choose my lowest moles, it's 0.194, and then because of that, I already know when I calculated the molar mass of sodium sulfate's 142.04. The question asks how many grams. So if I multiply that by the molar mass, I'm running out of space here, but 0.194 moles of Na2SO4 now, I'm choosing that because it's my lowest moles. If I multiply it by 142.04 grams per mole, 0.194 times 142.04, I get my answer of 27.6 grams. Right, so my theoretical yield, or the mass of sodium sulfate that should be produced, is 0.194 moles, and multiplying by the molar mass, that's 27.6 grams of Na2SO4. Okay, so that is another example. I'm going to post 2 more videos of 2 more examples of doing BCA tables with limiting reactant problems.